Hello everyone, welcome to this video on surds. So this is going to cover 12a1, 2 and 3. So a radical is any number which can be written with the radical sign, which is basically what we call a root as well. So then we have a surd is a real irrational radical, such as root 2, root 3 or root 5. Okay, so the distinction here between a radical and a surd then, okay, so root 9 is a radical. It's expressed as a root, but it's not a surd because the square root of 9 simplifies to be plus or minus 3. Okay, so a surd is only a number that doesn't have a rational square root. So irrational as well, that means it's going to have an infinite number of decimal places, and those decimal places would go on forever. So if we look at properties of surds, if we have the square root of AB, that's going to equal the square root of A times the square root of B. If we have the square root of A on top of B, that can simplify to the square root of A on the square root of B. And then if we've got one lot of root A plus another lot of root A, we've got two lots of root A. So let's get into these examples here. Simplify the following. Root 8 times root 8. So there's a couple of processes we could follow here, but what we're going to do is we're going to recognize that it's the square root of 8 times 8. Okay, so we're going to use our first property there. We've got root 8 times root 8. We can express that as the square root of 8 times 8, which is the square root of 64. And the square root of 64 is plus or minus 8. Okay, if we have 3 root 5 times 2 root 5. Well, when we've got multiplication right, the order of multiplication doesn't matter. So we can write this as 3 times 2 times root 5 times root 5. Okay, now we know 3 times 2 is 6, and root times 5 times root 5 is 5, and so that simplifies to be 30. Okay, so I'm applying that process that we did over here pretty quickly. You can recognize that this is another property we have. Root A times root A is equal to A. Okay, square root of 25 on 10. Let's split the square root. So that's going to be the square root of 25 on the square root of 10. And we know the square root of 25 is 5. Okay, so that'll do for there. If you put it in your calculator, it may simplify it using some other third operations. Okay, write in the form A root B. So what we want to recognize is we want to look at these numbers and go, what's the highest square factor that they have? Now, when we say factor, it means what are some of the multiples of it? What do you multiply to get it? So for instance, 18, you've got 1 times 18, and we've got 2 times 9. Okay, 3 times 6. So the highest factor, that's a square number, is 9. So we're going to write this as the square root of 2 times 9. Okay, we can then split the square root. So this becomes root 2 times root 9. And we know that the square root of 9 is 3. So it's root 2 times 3. And that the correct way we're going to write that is that's 3 lots of root 2. Okay, 3 root 2, that means 3 times the square root of 2. All right, if we have the square root of 125, we're going to write this as the square root of 5 times 25. Okay, 5 times 25 is the square root of 125. And that will be root 5 times root 25. And we know the square root of 25 is 5. So what we have here is 5 lots of the square root of 5. Okay. Let's move on to the bottom one here. Question 3, perform the following operations. So here we've got some addition. We've got 3 lots of root 5 plus 7 lots of root 5. Okay, 3 lots of it plus 7 lots of it. That leaves us with 10 lots of the square root of 5. Here we've got root 2 times, and then in brackets 2 take 3 root 2. So we need to apply the distributive law here. So that means that root 2 is going to multiply both terms inside the brackets. So if we've got root 2 times 2, that's going to be 2 root 2. And then we've got take 3 root 2 times root 2. I'm going to write this out in a number of steps here, the second part. So root 2 times 2 is 2 root 2. And then root 2 times 3 root 2, that's that statement there. And so we can see when we've got root A times root A, it simplifies to be A, doesn't it? So we've got 2 root 2 take 3 times 2. Okay, root a times root a is a, root 2 times root 2 is 2. So we've got 2 root 2 take 6 is what this example simplifies to be. Okay, coming up the top here with number 4. So some of these later ones are going to be a little bit more involved. To write with an integer denominator, we need to multiply it by, well, it depends. There's two circumstances. In this circumstance, we're just going to multiply it by 1. Okay, we can multiply by 1. We're not changing the value of it. But another way we could write 1 is 3 root 3 times root 3 divided by root 3. Okay, root 3 divided by root 3, that's just 1. But now, if we're going to perform this fraction multiplication, we have the top times the top. We get 3 root 3 at the top. And at the bottom, we're going to have root 3 times root 3. Now, root 3 times root 3 is 3. Okay? And what we'll notice here is this can simplify. We've got 3 at the top, 3 at the bottom, that can simplify. And now the simplest way to write this is root 3. That's what it does simplify to be. Okay, so that was A. Let's have a look at B. We're going to repeat the same process. We've got 2 on root 7, so we're going to multiply it by 1. What's another way we can express 1? Is root 7 on top of root 7. So now at the top, we're going to have 2 root 7, and at the bottom, we're going to have 7. Excellent. Let's move on to C. Okay, so C and D are going to be a little bit more complex. You can see at the bottom, we have 2 terms. We've got 2 and plus root 5. And so when we perform the multiplication here, we don't just multiply it by what's at the bottom, we multiply it by what is called the conjugate at the bottom. So if we have 2 plus root 5, then the conjugate is 2 take root 5. Okay, and I'm going to show you why we multiply, when there's 2 terms, why we multiply it by the conjugate now. Okay, so what we've got, at the top we've got 3 times 2 take root 5, so that's just going to distribute, isn't it? That's going to be, and I might just split this page here so we can do D here. That's going to just distribute, so we'll have 6 take 3 root 5 at the top. And then at the bottom, we've got 2 plus root 5 times 2 take root 5. Now, you could go ahead and perform that using FOIL, but I'm going to show you guys a quicker way. The reason we've set this up is because you should remember, if we have a plus b times a take b, that simplifies to a squared take b squared. Okay, so at the bottom here, we've got 2 plus root 5 times 2 take root 5. So it's going to simplify to 2 squared take root 5 squared. All right, because it is a difference of 2 squares expansion. So at the top, that's going to remain as it is. We've got 6 take 3 root 5. There's not an apparent way to simplify that. And at the bottom, we're going to have 4 take 5. Okay, 4 take 5 is minus 1. Okay, so we do have the correct answer there. We've got 6 take 3 root 5 on top of minus 1. But then again, that minus 1, we can perform that division. It could become minus 6 plus 3 root 5. Okay, so look at what we started with. We started with 3 plus 2, where is it up here? We started with 3 on top of 2 plus root 5. And then we simplified it to minus 6 plus 3 root 5. Okay, so now we don't have a denominator at all. And we did that by multiplying it by the conjugate. Let's have a go at D, example D. We've got 2 root 3 on 4 take root 5. Okay, so same step again, we're going to multiply it by the conjugate. Now, if we have 4 take root 5, the conjugate is 4 plus root 5. Okay, so what do you notice? It's the exact same terms, but you're changing the symbol in the middle. Okay, and 4 plus root 5 divided by 4 plus, that's still 1. So we're not changing the value of this term in any way. It's a legitimate operation. So at the top, we've got 2 root 3 times 8. That's going to become times 4. That's going to become 8 root 3 there. And then we have 2 root 3 times 5. I might perform that one a bit separately, just so we can see pretty clearly what's going on. So that's times the root 5 over there. And at the bottom, we've got a take b times a plus b. We've got that difference of 2 squares expansion again. So that's going to simplify to be 4 squared take root 5 squared. Okay, so at the top here, we've got 8 root 3 plus 2 times root 3 times root 5. We can write that as, I'm doing it in a number of steps here, root 3 times 5. Okay, and then at the bottom, we've got 16 take 5. And so we've got 8 root 3 plus 2 root 15 on top of 16 take 5 is 11. And we're done. We've simplified it, and now you notice the denominator is an integer. That's what it's asking us to do. Write with an integer denominator. An integer is a whole number. So, complete. So that's an introduction to Surds. That's exercises 12A.1, 12A.2, and 12A.3.